Okay, so welcome to Dr. Armand's lecture for today. We're going to be discussing how to calculate the rate law for a reaction. So what I have up here is some experiments where we've had changed the concentrations of our reactants and calculated the initial rates. And so this is a very generalized equation. A plus B gives us C, and we want to determine the rate law. So the general form of a rate law is rate equals K, A to the N, B to the N. And this is a two reactant system. You can have one reactant systems, you can have two reactant systems, and three reactant or more systems. And so M and N are called orders of reaction. They tell you how the concentration affects rate. For example, if M is 1, if you double A, you're going to double the rate. If M is 2, you double A, you're going to quadruple the rate. It tells you how much concentration affects the rate. And then M plus N is referred to the overall order of reaction. Again, M and N are determined from experimental data. And then K is the rate constant. So we're going to determine all of these from this set of information to give us the rate law for this equation. And the way we're going to do this is using the initial rates methods. So you take two experiments, we'll say rate 1 over rate 2, K, A1 over M, over A2 to the M, B1 to the M, B2 to the M. So here what I've done is you take two experiments, you got the rates for each experiment, experiment 1 and experiment 2, you got the rate constant, you got concentration A in experiment 1 and experiment 2, and the concentration of B in experiment 1 and experiment 2. And so what we're going to do is to determine the order of reaction M, we're going to pick two experiments where B is constant and A changes. So when we do that, when B is constant, this cancels out, and this cancels out. When concentration of B is constant. So we can do this when the concentration of B is constant. These cancel out. So you're going to pick two reactions where this changes, but this does not change. So that cancels out. Then we get rate 1 over rate 2 equals A1 over A2 to the N. Now we can determine the order of reaction for A. So rate 1 So we have this now to simplify it a little bit. Get the trusty calculator. Get 0.125 equals 0.5 to the N. Now if I write this as nice fractions, we see that 1/8 equals 1/2 to the N. Now most of the time you can look at this and by inspection determine the power of M. But if you can, you can always take the ln of both sides and determine it. So here I know that if I cube 1/2, I get 1/8. So A here is a third order reactant. So that's 1. Now we're going to do the same thing now with B. Since we know what A is, for B it's not imperative that you pick two experiments where B changes and A is constant. You can pick any set of experiments now that we know what A is to determine the order of reaction with B. But what I'm going to do is I'm going to pick two experiments where B changes and A is constant. That way it's just less steps you have to do. So I'm going to choose experiment 1 and 3. Again, you don't have to, but I just like to because it reduces the number of steps I have to do. Alright, so now let's set this up for solving for B. I'm going to choose experiments 1 and 3. So that's experiment 1. And experiment 3. So again, experiments 1 and 3, A is constant, so they cancel out. B changes, that's what I got here. And so we get, simplify it, 0.5 equals 0.5 to the n, or we can write it as nice fractions. 1/2 equals 1/2 to the n. So now, again, by visual inspection, usually you can determine what the value of n should be. So what power do we raise 1/2 to get 1/2? And the answer is 1. So B is a first order reactant. So if you didn't know this, you can always take the ln of both sides. When you take the ln, so ln means that this n comes in front, so we get ln of 1/2 equals n ln of 1/2. Divide each side by ln of 1/2. Ln of 1/2, this becomes 1. So n equals 1. So either way you can do it, it'll work. So now we know that B is a first order reactant. Now we know the orders of reaction, we can determine the rate law for this equation. Now for the rate law, you just have to pick one of these experiments, plug in your concentrations and rate, and solve for K. Doesn't matter which one because rate constant is a constant. Just choose one of these, plug it in, solve for K, and that's your rate constant. Now if you're doing this in the lab, what you should do is for each experiment, calculate K, and see if you get the same answer. If you get the same answer, that means your data at least makes some sense from the experiment. Now if you get a different answer for the rate constant, that's not good. So now what we're going to do is I'm going to choose experiment 1 and calculate the rate constant. So we have when we solve this, we get $425. So this is our rate constant here, and therefore we get rate equals 425 concentration of A to the 3, B to the 1. Now if you want to know the units for the rate constant, so this is molarity to the 4th, so our units for K, if you're interested, would be, let's see, M over S over E to the 4th. This would be units of K would be S to the -1, M to the negative. Well, we should write that M to the -3, S to the -1. So these are the units for K for this rate constant. And so now this is our rate law. So now you can plug in any concentration of A and B and calculate the rate for it. And this again is the process you go through when you want to solve a rate law using the initial rates methods. Hope this has been informative for you, and good night, or good day I should say.